So in question number 18, a ray of light traveling in air is incident at an angle of incidence I is equal to 90 degree on a long rectangular slab of a transparent medium of thickness y0. The medium has a variable refraction index which is given by under root 1 plus e raised to the power 2x by a for all x greater than equal to 0, where a is a positive constant. If y0 is equal to a by 2, then x coordinate of the point where the ray intersects the upper surface of the slab air boundary is a ln n. Find the value of n. So it is given in the question at t equal to 0, the ray incident at this point and the refractive index is varying along x-axis. So at this point, if I draw the normal is in this direction. So the angle of incidence is 90 degree. Since as x increases, mu increases, so the ray will deviate towards the normal. So it will go in this way. So suppose the ray will go in this way. So suppose at any time t, when the ray is at this position, let the coordinate of this point is x comma y at that moment, and let the tangent at this point makes an angle theta with the x-axis. So this angle is theta. So if I apply the Snell's law at this point as well as this point, then I can say that 1 into sine 90 degree, that is 1, is equal to mu at that point, that is mu, into sine theta. Let the normal at this point is in this direction. So suppose this is the angle theta, this angle or this angle. So from here I can say that sine theta is equal to 1 by mu, and tan theta can be written as 1 divided by under root of mu square minus 1. So we know that dy by dx is equal to tan theta, and it is equal to 1 upon under root mu square minus 1. So if I substitute the value of mu here, I will get e raised to the power minus x by a. So now we have formed the differential equation. So I can write dy is equal to e raised to the power minus x by a into dx. So at x equal to 0, y is equal to 0, and at x, y is y. So on solving, we will get y is equal to a into 1 minus e raised to the power minus x by a. So in the question it is given that if y0 is equal to a by 2, so if the value of y is a by 2, then at that moment what is the value of x? So it is equal to a into 1 minus e raised to the power minus x by a. So on solving, we will get e raised to the power minus x by a is equal to 2 raised to the power minus 1. So if I take ln, then I will get x by a is equal to ln 2, or x is equal to a ln 2. So if I compare, then the value of n comes out to be 2. So the correct answer for question number 18 is 0, 2. Let's move to question number 19. In question number 19, a point object O is placed on the principal axis of a silvered equiconvex lens at a distance x so that its image coincides with the object itself. If the radius of curvature of the surface of lens is 10 cm and the refractive index of material of lens is 2, then find the value of 3x. So if I apply the concept of equivalent power, then P equivalent is equal to 2 times power of lens plus power of mirror. If the rays are converging, then we consider power as positive, and if the rays are diverging, then we considered power as negative. So we know that power of lens is equal to 1 upon f is the focal length of the lens, and power of mirror is equal to minus 1 by f. Again, f is the focal length of mirror. So in order to calculate the power of lens, suppose this is a lens and it is given in the question that its radius of curvature is 10 cm and its mu is 2. So if I calculate the focal length of the lens by applying lens maker formula, then 1 upon f is equal to mu2 minus mu1 upon mu1 into 1 upon r1 minus 1 upon r2. So 2 minus 1 divided by 1 into 1 by r minus of 1 upon minus r. So on solving, it comes out to be 2 by r. So the focal length of lens comes out to be r by 2, and it is equal to 5 centimeter. So I can write 2 times 1 upon 5 plus power of mirror. So minus 1 upon, now the focal length of mirror. Suppose if I consider this part, then the radius of curvature is given 10 centimeter, then the focal length will be 5 centimeter, because in case of concave mirror, f is equal to r by 2. So it can be written as minus 5 centimeter, because focal length is negative in this case. So on further solving, it comes out to be 3 by 5. Since the power comes out to be positive, it means the equivalent will behave like a concave mirror. So if I calculate the focal length of the equivalent concave mirror, it can be written as minus 1 upon f equivalent. So from here, the value of f equivalent comes out to be minus 5 by 3. So it comes out to be negative, which is the focal length of the equivalent concave mirror. So suppose this is my equivalent concave mirror, and this is the object, and it is given in the question that the image coincides with the object itself. So in order this to happen, the object must be kept at the center of curvature of the equivalent concave mirror. So I can say that this is equal to 2 times f equivalent. So the value of x is equal to 2 times f equivalent, that is 5 by 3. So it is equal to 10 by 3 centimeter. Now in the question, it is asked what is the value of 3x. So the value of 3x is equal to 10 centimeter. So the correct answer for question number 19 is 10. Let's move to question number 20. In question number 20, in a standard YDSE arrangement, 2 glass plates of thickness T and 2T and each of refractive index mu is equal to 2 are introduced in front of slits S1 and S2 respectively as shown. If delta x is the shift of central maxima on a screen with respect to point O, then find the value of 5 into 10 raised to the power 5 into delta x in meter. So if I write the part difference for the central maxima, let the central maxima is at this point, and this is given delta x. So I can write part difference delta x dash for the central maxima is equal to delta x small d by capital D plus 2t into mu minus 1 minus t into mu minus 1. So this is the additional part difference due to introduction of these two slits. So for central maxima, the part difference delta x dash must be equal to 0. So from here, if I solve, the value of delta x comes out to be minus capital D by small d into t into mu minus 1. So if I substitute the data, so value of Td by d is given in the question, that is 1 by 100 into millimeter. So I can write in meter, that is 10 raised to the power minus 3 into 2 minus 1, that is 1. So it is equal to minus 10 raised to the power minus 5 meter. So negative sign indicates that the central maxima shifts to downward position. So we have to calculate the value of 5 into 10 raised to the power 5 into delta x. So that is 10 raised to the power minus 5. So it comes out to be 5. So the correct answer for question number 20 is 05. So by this, I wish you all the best for the preparation. Have a good luck. Thank you.